Hello everyone, welcome to Olsen Cafe. Now in this lesson, we are going to solve trigonometric equations involving Pythagorean identities. But before we move on, make sure that you have watched my previous video on the fundamentals of solving trigo equations, which cover the three key steps that you're going to apply in solving equations. Yeah. Now, so let's move on. So in this case, we have 3 cosine squared theta equals to 2 plus sine squared theta. So let's see what are Pythagorean identities and how they can be applied over here. Alright, so over in these slides, what you see are the 3 Pythagorean identities. These are very commonly used, right? And you should be very familiar with all the 3 of them and know how to apply the 3 identities. Now let's move on to see how can we apply these identities, all right, into solving the equation. So as you can see in this question, all right, we have 3 cosine squared theta equals to 2 plus sine squared theta. So there are 2 functions involved. Yeah, and I mentioned in my previous lesson, whenever we solve trigo equation, yeah, there should not be more than 1 function. So which means we will have to simplify. So some of you may say, oh, so if I simplify, can I straight away just change it to tangent squared theta? The answer is can, but before we convert it into tangent, we do need to remove this obstacle because there is a tool here. All right, so therefore in this question, I'm going to demonstrate to you how can we actually apply Pythagorean identities to get rid of these two before we can even convert this equation into a tangent. Yeah, so since cosine square and tangent square involved. So I do know that there is a Pythagorean identity that is sine square plus cosine square theta is equals to 1. So by applying this identity, I sub inside the equation and this is what I will have. Now, so what I will want all of us to observe here is, all right, to take note of this. Right, I have sine square theta plus cosine square theta. So this itself is equals to 1. So this gives us 1. Yeah, so basically 2 times 1 will give me a 2. Yeah, so with this, this is a very useful strategy that we can do, right, whenever we come across a constant value, all right, and then we are trying to simplify it. Yeah, so do take note of these tips here. Now, so once I have this, I can simply expand and simplify till I get cosine square theta equals to 3 sine square theta. And with this, then I can convert this equation into a tangent. Yeah, so with this, I will get tangent square theta equals to 1/3. And I have also mentioned in my previous video, all right, that when we have a square, an exponent, right, tangent square, when I take the square root, all right, we should remember to have a plus and minus sign involved. Now that we have this, right, we will need to consider some key questions. Yeah, so what are the key questions that we need to consider before we solve the question? So these are some of the good habits, all right, that you should build, all right, whenever you solve trigo equations. But before we move on to the the key questions here, let's recall the key steps, right, which I covered in my previous lesson as well. So the key steps involved for us to solve trigo equations will be identify the quadrants. Yeah, so therefore when we take a look at this, right, we have tangent theta equals to plus and minus, right, 1 over square root of 3. So I have also previously demonstrated whenever there's a plus and minus sign, when we consider the 4 quadrants, so what angles, what quadrants will theta be in, right? Will it be in all the 4 quadrants? So you can see if tangent is positive, therefore which quadrant, all right, will angle theta be in? And when tangent is negative, then therefore which quadrant will theta be in? So these are the things that we want to consider. All right, then the other thing that we also want to consider and to ask is theta in radian or degree mode. Yeah, so and then lastly, right, is theta the special angle. Right, so when we talk about special angle, we take a look at the value here. So if you are familiar with the table of special angles, right, so you should familiar and to recognize that this with this value 1 over root 3, this should give you theta as a special angle. So these are the things that we need to be familiar with. Yeah. So let's back to the range given here. So if you take a look, all right, theta is actually between 0 and pi. So therefore, this given range here will have an impact, all right, for us in answering the 3 questions. Yeah. So with this, because theta is only given from 0 to pi. So from 0 to pi, that means I only need to consider the first or the second quadrant. You will notice that third and fourth quadrants are not included over here. So therefore, my theta, right, should only be involved in the first and second quadrant. And with this, then we move on to find the basic angle. Yeah, so basic angle, I just simply take 1 over root 3. All right, and sum into using a calculator, I should be able to find the answer as pi over 6. Yeah, and again, I want to emphasize, because I know that theta should be a special angle, so therefore, as far as I can, I leave the answer in terms of pi, the basic angle in terms of pi. And since theta is in the first or the second quadrant, so therefore I can work out the first quadrant, answer is pi over 6, and then the angle in the second quadrant, I just simply take pi minus of pi over 6, which is pi minus alpha, so that will give me 5 pi over 6. Yeah, so with this, hopefully this simple example illustrates how we can actually apply Pythagorean identities into solving simple trigo equations. I hope you find this useful. All right, I see you in the next video. Thank you and bye.